lectures that I'm trying to get to you as quickly as I can are farmland habitat, forest land habitat, and wetland habitat. We got through the farmland. I'm going to start talking about forest management today. And what I'm going to do is I'm going to get maybe halfway through this lecture, and then we're going to go to the field, okay? And in the field today, we're going to look at a little bit more early successional habitat, and then we're going to look at some forested habitat as well. So today is going to be kind of a little bit of each from the field day. Then we come back to class Wednesday, and we'll finish this lecture. And then next Monday, we'll finish the lecture. And then next Wednesday, we're scheduled to meet Damon Hollis, who's a TWRA West Tennessee forester. And we're going to look at wetland forest management. So we forests grading into wetland. Okay, so we're just kind of gradually moving from early successional farmland to forest land to wetland. Good? Okay, good deal. All right. Who's heard of land capability classes? Anybody? It's more of an agrarian, agricultural, row crop thing. This is something that's historically been used by agricultural folks, soil conservationists, agronomists, to describe the quality and the potential of soil for growing vegetation, crops and other vegetation. The land capability class system has 8 classes ranging from 1 to 8. 1 is the highest and 8 is the lowest. 1 is soil that's very fertile. It's got great potential for growing stuff, and it's usually in great condition. It's not badly eroded, and it's actually so good that it would really be hard to screw it up. Okay, so it's not even very erodible. So think about, like, if you've driven through like the beautiful farmlands of Illinois that have the black soils that grow such productive crops. That's capability class 1, okay? Usually has just barely a slope, just enough of a slope to keep it well drained, but not much. Deep organic layer. Soil capability class 2 is still really good. You know, you've got maybe a little potential for erosion, but it's not degraded, it's in great shape. Soil capability class 3, yeah, okay, it's still, you know, very productive, but you've got potential for erosion, and you probably need to practice conservation measures, no-till agriculture, maybe leave it fallow every few years, take more measures to be sure that it's not going to degrade too badly. When you get to capability class 4, that's the lowest class that they suggest it's still okay for growing row crops on, okay? You might be dealing with some more significant slopes. It's more highly erodible. This is land that maybe has been degraded and that can easily be degraded, that we should definitely practice no-till or conservation tillage, that we should definitely fallow every now and then, you know, crop rotation, all those regenerative agricultural practices, leaving, you know, cover crops on it in winter and all that stuff, okay? Class 5, 6, 7, and 8 gets worse and worse and worse, and by the time you get to capability class 8, it's soil that's so poor and so eroded and degraded that it's difficult to get anything to grow on it at all, and you're just trying to restore a site. So think like, classic example is, who's familiar with, does anybody know the history of Polk County, Tennessee, in the far southeastern corner of the state? What happened? What did we do to the land in Polk County? You know, do you know, Piper?
It's not great.
Yeah, no, it's in poor shape. Historically, there was copper mining that occurred there, and it was done in a very exploitive fashion, and the land was degraded and heavy metals exposed, and no regeneration attempted whatsoever. And so there's no organic matter, and they've been working for, you could actually see bare ground from spacecraft. It was so bad. So they've been working for decades to just try to restore it, to get plants to grow again. That's capability class 8. But a lot of those other places is where you have between 5, 6, and 7 is where really the best thing that you should grow there is trees. Long-term cover where you're not going to be taking anything off, and it's slowly going to restore that site over decades and decades, okay? And then that brings us to another way of measuring the potential productivity of a site index. Land capability classes is usually kind of a language, an index used in agriculture. Site index is used in forestry, okay? It's not about the productive potential so much for crops as it is the productive potential for trees, how fast trees can grow, okay? So what site index refers to is, on average, what's the height of a species of tree per time? Usually we'll say for 50 years, and we do it by species. So if it's a site where we typically grow white oak as a common timber species goal, we would say the 50-year site index for white oak here is 60 feet. And that means on average, you could expect a white oak planted 50 years later to be about 60 feet tall. So that's just, it's an index of the productive potential of the site. Okay, good. When we're figuring what we're going to use land for, we look at, we have to consider, what's its history, what's it currently being used for, and what are our future needs and goals. And one of the things I've said to at least one or two of you in here is that it's pretty common when you guys are working on management plans, when a farmer shows you a farm that let's say that this half of the farm, is my row crop fields, and this half of my farm is the forest. And if you look at the soil map, it's not going to look like this. Your row crop field is highly erodible soil, and your forest is very fertile, non-erodible soil. Usually it's going to be the other way around, okay? But what you often can look at is if it's a farm that's been well established for a long time, there might be part of a row crop field that's got some slopes and it's highly erodible and it has a history of erosion. And there might be part of his pasture or wooded area that's not highly erodible at all. And it's okay to say, if you got a row crop this many acres, take this part of your field out of row crop production, plant it into woods, or at least prairie, and then take this part of your timber and you can put into row crop production. It's not going to erode that bad. It's okay to switch what they're doing where in your recommendation. Does that make sense? And most people are kind of hesitant to do that. It's like, this is his field, man. I don't want to mess with his field. If his field's not in the right place, it's okay. It's your job to let him know. So when it comes to forest management, typically this is done historically with timber production in mind. Even in wildlife agencies, typically, when they have forest lands, they'll hire foresters, and foresters are trained usually, as timber production managers, right? And I'll tell you guys, what's good for timber production is often not the very best thing for wildlife habitat. So we have to be very careful and take what they say, not with a grain of salt, because a lot of what they say and know to do is correct, but you have to be real clear about, okay, why are you wanting us to do that? This is what my goals are. Tell me how to meet my goals. So for example, they might say, this stand is 80 years old. It's time to harvest it now. And you might say, why? And their answer is, because it's reached its maximum, size potential. Its growth now is going to be much slower. The trees are going to start to senesce and die and get heart rot. The quality of the wood is going to go down. So you're actually going to lose value in this timber stand over the next 2 or 3 decades. And if you say, yeah, but my goal is to grow more cavity trees for bats and cavity nesting species, then you're getting rid of the trees just when they're getting ready to start creating cavities, right? And from a timber harvester's perspective, cavities are bad, but for wildlife, that might be exactly what you're trying to get, and it's taken you a century to get there, right? So it's important that you communicate very clearly with them. So forest management, when it comes to managing timber where you are going to be harvesting it, there's 3 stages to it. Who's taking silviculture? Nobody's taking silviculture? Good. Who is this new to? Excellent. All right, good deal. So what it involves is, we can start anywhere because it's a cycle. We harvest our trees, okay, and we do that quickly. And then we are regenerating a new stand of trees, and that takes That takes a long time. How long does it take from planting to harvesting for traditional hardwood saw timber around here? About how many years? I think I might have just said it. 80. About 80 years, yeah. For pine, more like 40. For pine pulpwood, you can do a thinning at 8 years, at 15 years, at 30 years. So pine grows a lot faster, right? So we can harvest it faster. But hardwood, depending on what we're growing, if we're growing pulp, just a few years. If we're growing pole timber, a few decades. If we're growing saw timber, about 80 years or so, okay? So we're regenerating that stand, letting the new stand grow, and well, actually, regeneration refers to getting a new stand established, and then once it's established, this is the long process, what you do to it while those trees are growing. And what most people do on private lands, non-industrial private forests, NIPFs, okay? That's the forest on my land and on your property if you have any. What most people do is nothing. They just let them grow, right? But there are things that we could do. We could thin, we could burn if that meets some particular goal. And some people who are managing intensively will even do things like prune and even fertilize. But that's for like hardcore, really trying to hasten production to get a lot of profit, okay? So we're growing the stand and doing stuff while it's growing. We harvest, we reestablish to start all over again. And that's the cycle, okay? And when it comes to harvest, there's a few different ways we can do it, okay? Those systems are either ground-based or air-based. Air-based are usually much more expensive, and we don't usually see that around here. Where we see air-based is typically where you have very remote regions very high value, high quality timber. So this is often old growth forest in very remote regions where, in the southeast we don't have that anymore. That's long gone. So what we usually use in this part of the world is ground-based systems. They're cheaper. You tend to have potentially more problems with soil erosion and ground compaction and damage to the other trees. So you have to be careful. The most simple way of doing it is with a sawyer, a skidder, and a loader. The sawyer is the guy or gal with a chainsaw, right? The skidder is the machine that picks up the logs and drags them to the loading platform, and the loader is another machine that picks up the logs and puts them on the logging truck to drive them away. Okay, that's traditional. More today, especially in flat areas where we have production agriculture, we have machines called feller bunchers. I love that name, feller buncher. The name makes me happy. I don't know why. It grabs a bunch of trees, chops them off, and puts them on the truck. It's an expensive machine, super efficient, very impressive to watch. You can strip all the limbs off. Has anybody seen one of these at work before? Where'd you see that? It's pretty impressive, isn't it? Yeah.
I went to the forestry meeting in high school.
Oh, excellent. Good. Did you see feller bunchers there?
Yeah, we went to the thing where they were cutting down and doing the process.
Yeah, very cool, right. Another type of a system, you see this more where you have contour, you don't want to be driving up and down steep slopes, is you have a platform, a loading platform at the top of a slope, and let's say it's a slope that goes down all around. You cut all these trees down, and you've got a cable that you let out and you attach to a tree, or 2, 3, or 4 trees, and you drag them up the slope. Drag them up the slope, drag them up the slope, drag them up the slope, right? And then you've got a loader that loads them onto the truck to go away. That cable system, a ground-based cable system, is a pretty cheap way to do it, but you can imagine the damage it does to the soil, creating those divots as you're dragging these logs that might weigh tons up the slope. Great potential for erosion, right? So that's not great. Probably the most the smallest ecological footprint you could leave logging is with the old school mule logging, where you just you cut a tree, hitch up a mule to it and drag, with a mule, just drag that log up to the loader. But you can imagine that's the slowest from economic productive potential today. When you're comparing it like to a feller buncher, nobody much wants to do that, and hardly anybody does it anymore. There are some folks who do, and the Tennessee National Wildlife Refuge did a timber harvest at their Big Sandy unit several years ago, and they tried real hard to get a mule logger, and they thought they had him lined up, and I think he got old or his mule got sick or something. They couldn't find another one, so they didn't end up doing it. But that was their preferred system because they weren't doing it for money. They were doing it to minimize ecological impact and maximize the quality of the habitat. So that's still a thing out there. Air-based systems can be helicopter, or it can be a cable system that's suspended above the ground, like a ski lift, okay? Lifts the logs up and carries them up. Much more expensive to set up, you can imagine. So this is for very special, sensitive habitats, very high value trees, right? I had helicopter logging going on my study area in northeastern Oregon where, there were old growth Douglas fir trees, big trees. And there are, who's familiar with best management practices for forestry? Have you guys heard of these before? These are developed by the U.S. Forest Service, BMPs. And it's a set of guidelines for how to do timber harvest in a way that minimizes ecological impact, especially with regard to streams and water, but also with regard to soil. These, for the most part, are not laws that we have to follow, but they're guidelines. Now, there are some states and situations where, for example, let's say that a farmer goes into a conservation program with NRCS, and there's going to be some sort of a timber harvest, and then they're going to reestablish native timber there. Maybe the NRCS contract says you are required to follow best management practices guidelines, so they could do something like that. But these are not just general laws that everybody has to follow. They're just good guidelines that you should follow. So if on your private land you contract with a private timber harvester to harvest your forest, you could say in the contract, you could stipulate, you are required to follow best management practices. And if you don't, you will be in breach of contract, right? So you can do that if you want to, as long as they agree to it. There are BMPs for other things too, like trapping. These are not laws, how you have to trap, but how we recommend that you trap. So, okay. And then there's regeneration, how we harvest trees and how we put trees back in. That rotation or silvicultural strategy can come in two major flavors, and those flavors are even-aged management and uneven-aged management. Know this, you will see this, okay, in the 5 categories underneath. So even-age management, when most people think timber harvest, what they think is clear cut, all right? But that's one of 5 different ways you can do it. What most people think of as the alternative to clear cut is selective harvest. And my response to that is, what do you mean by selective harvest? That term is too broad. Hear me. In this class, do not use the term selective harvest. I will throw things at you, okay? I promise, all right? You may use group selection or single tree selection, but you may not use selective harvest. It's too broad, too vague. And I'll explain why. So, when most people think timber harvest, they think clear cut. How would you define a clear cut? Every tree. You're cutting every tree in a given area. That's right. And how big does the area have to be considered a clear cut? How big does it have to be when a stream becomes a river or a pond becomes a lake, right? It's kind of subjective, but some people would say at least 3 or 4 or 5 acres. 10, 15, 20 acres is common, but there are clear cuts that are 50 acres, 100, 200 acres, 1,000 acres. We don't usually, we kind of frown on really super large clear cuts anymore. Is a clear cut ecologically bad? Is a clear cut bad?
Not necessarily, especially if you're trying to do more prairie or grassland habitat rehabilitating, or if you need something for like rough grouse, you need a clear cut area.
Perfect, yeah. So you say not necessarily, which implies that a clear cut can be done badly or in the wrong place or the wrong way. Yeah, a clear cut's a tool, like a shovel. Did I give you this example? You can use it to dig a hole and plant a tree, or you can bonk somebody over the head with it, right? So it's just a tool. It's often used poorly, but in and of itself, it's not bad. If I clear cut all the timber on my property next spring and don't replant, how long will it take for a forest to start growing back? You say not long? What do you mean by not long?
Not long in comparison to trying to plant it into just entirely new forest.
It's gonna start growing back immediately. And I don't mean that seeds are gonna start sprouting, I mean that the stumps are gonna start sprouting, and that's called coppice regeneration. We don't see that with pines, but we see it with a lot of hardwoods, okay? You cut a tree and a sprout comes out, a sucker, a sprout, that's called coppice regeneration, and whole trees will come out of that, okay? So, yeah, clear cuts can regenerate very quickly. All right, the other two types of even age management are seed tree selection and shelter wood selection. These are like clear cuts, okay? You're cutting everything, except with seed tree selection, you're leaving just a few trees that have big canopies and they're good seed producers. And these are species that you want to drop seeds that will represent the next generation, okay? So they're gonna drop seeds, so your the next plants that come up, those guys are gonna seed it for you, so you don't have to, okay? A shelter wood is a little bit more specialized. Again, it's like a clear cut. You're leaving a few more trees, okay, that are gonna provide canopy, shelter. They're gonna shade the place somewhat, okay? So these are a few big canopy trees. And they're also gonna serve like seed trees. They're gonna drop seeds and stuff, but more importantly, they're gonna shelter it, they're gonna shade it, so that only the trees that the next generation, only ones that are gonna come up are gonna tend to be somewhat shade tolerant. So if you want your next generation to be a species or a combination of species that are shade tolerant, you leave those shade trees on the shelter wood cut to shade out the shade intolerant species, so the shade tolerant ones can come up, okay? Does that make sense? I'll show you pictures of all these in just a minute, what they look like. You'll see this on the test, okay? If I ask you what's the difference between a seed tree and a shelter wood cut, you'd say, well, they're both two types of even age management other than clear cuts. Seed tree, there's a few trees that provide seeds for the next generation. Shelter wood, there's a few more trees that provide shade so that the next generation is shade tolerant. Good? Okay. And these are all even aged management. Now, with clear cut, it makes sense, right? You got trees that are all kind of sort of one age, you cut it all, and everything starts growing at the same time, right? So you have one age of tree. Do you have 5 years later a tree here and 10 years later a tree there that grows up? Yeah. Is every single stem, every single tree the exact same age? No. But generally the primary generation is all about the same age, all the years or so from each other, right? In these two, there's a time period when you cut most of the trees, but you still got a few, and then you've got another generation coming up. So you'll have two different ages, right? And then very often, once this generation comes up away, you cut the big ones. You cut those few seed trees or those few shelter woods to release everything else, right? So for a while, you have two ages, but it's even. It's either one age or it's two ages, but it's not a whole bunch of different ages, right? What does it take to get an uneven age stand? Well, there's a couple things you can do. One thing you can do is wait about 200 or 300 years. And what happens, right? Different species die at different times and storms, and red oaks die after 100 and 150 years, white oaks die after 300 to 500 years. So after a few centuries, you've got all different ages growing in the forest, right? It's an uneven age stand. Or you can do uneven age management by selective harvest, a term I don't want you to use. Selective harvest can be single tree selection or group selection. When most people say, and if you say, hey, I want to have my timber harvested, but I want it done very carefully. I like my woods and I don't want them to be messed up too bad. There's a lot of timber companies that'll come in and say, oh yeah, we'll do selective harvest. We're just going to take a few trees out here and there. You won't even know we've been there, right? Caitlin, if I tell you that I want you to go onto a property, we're going to harvest some trees for profit, go onto the property and pick 3 trees per acre to harvest. Are you going to randomly go out with your paint can and mark 3 random trees? Or you're going to be keying in on trees with certain characteristics?
Probably keying on them. Keys.
You're gonna key in on trees with big trunks, a species that you know is valuable, that has a tall, straight trunk, right?
Mhm.
What are you taking? You're taking the very best trees. And if 20 years later you do that again, and 20 years later you do that again, and 20 years later you do that again, at the end of a few decades, what's your stand gonna be? Shit, is what it's gonna be, okay? And that process has a term. Who knows what it is? It's called high grading. High grading. Highgrading, high grading. It's taking the very best trees. And even if you don't mean to do it, you might do it. Here's what those timber guys who are non-ethical or non-educated will say. Well, for example, right here you have 2 oak trees. You've got this big one right here, okay? It's about 20, 22 inches, 24 inches DBH with a nice straight trunk and real tall and a big canopy. And you've got a small one right next to it. And the small one is only about 8 inches DBH and it's only about 30 feet tall. And you can tell it's getting repressed by this big mean bully of a tree right here. And if I cut this big mean bully of a tree and take it away, the little tree that's been repressed will be able to grow big, right? And that's how we facilitate a stand. This younger tree will be released. It's not a younger tree. You have 2 oak trees growing side by side like that, one's bigger than the other, they're probably sibling trees. The bigger one had better genetics and it outcompeted the bad one, okay? You get rid of the big one, this little one is what you have left. It's gonna grow, it's gonna be released, but it's not gonna be a superior tree, right? So you're just degrading your stand more and more. So don't do that, and don't let people do that or say that. Is there a place for single tree selection? Yeah, there is. But single tree selection for wildlife management is very different than single tree selection for profit, right? We might be selecting, hey, maybe we've got some trees that aren't very useful for wildlife. Maybe we've got some sweet gums, poplars, and we want more hard mass producers. So we're gonna cut more sweet gums and poplars, even though they're good timber trees. Maybe we've got a stand that's 90% white oak, and white oak is great, but I want more diversity. I want some other species too. So maybe I am gonna focus on white oak. Some of the big ones, but maybe even more of the small ones to let those big ones get bigger faster. It just depends on what our goals are, okay? That's single tree selection, got it? Take a tree here, a tree there, just a few trees per acre. Group selection is kind of like single tree selection, is kind of like clear cuts. Group selection is a small clear cut, okay? So imagine, for example, that you've got a farm, that's not working. You've got a property, and here's a bit of timber and here's a bit of timber, right? And this is a timber stand that's 15 acres, and here's one that's 20 acres, and if I cut the whole thing, that's a clear cut. If I come in here this year and I cut a couple acres there, a couple acres there, a couple acres there, I haven't cut the whole stand. I've just cut a chunk out of it, right? That's called group selection. Maybe I come in 10 years later and I cut here, here, and here. And I come in 10 years later and I cut here, here, and here. And I keep on doing that, right, every little while. And at the end of so many years, what do I have? I have a very uneven age stand, right? It has even age little patches within it, but overall it's uneven aged. Guys, I really like group selection. I think that if somebody doesn't want to take out an entire timber stand and start over again, then group selection is a great way to do it, because it's really, really hard to accidentally high grade if you're doing group selection, because you're just picking a spot, right? Now, let's think about this. Did I give you guys the term the other day, aspect, a couple weeks ago? Yes, I did, but you don't remember what it is. It has to do with the slope. Does that remind you?
Oh, yeah.
What is aspect? It's the direction of the slope. North aspect, south aspect, right? And what did I say about a north aspect versus a south aspect?
Sunlight.
What's that?
Sunlight.
Yeah, and what about sunlight?
You get sunlight More in one area that we.
Which one? We're in the northern hemisphere.
The north.
No, sun is over the equator, which is south of us, right? So sunlight is hitting that south slope more than the north slope. Make sense?
Yeah.
Does that make sense?
Yeah.
Are you with me? Okay. So think about this, okay? A single tree comes down and you've got a gap in the canopy, okay? As big as that tree's canopy was, right? Now if that sunlight is not directly overhead, it's to the south of us, it's hitting that canopy gap at an angle. We're not necessarily going to get much sunlight on the forest floor from just one tree falling. Now, if you know the bigger the canopy gap, the more sunlight we're going to get. So if one tree falls, if we do single tree selection, it's really not going to be very easy to grow, to quickly regenerate a stand of shade intolerant trees that need sunlight, because you're going to not get that much sunlight from one tree falling. But with a group selection cut, if it's big enough, if it's bigger than say a quarter of an acre, if you get up to half an acre or an acre, you're going to get more sunlight on the forest floor, and you can easily get those shade intolerant species, those species that need direct sunlight to grow. Does that make sense? Are you with me? You understand that? You're going to remember it? Okay, good. So I really like group selection as a tool for private landowners. There is a time that I think a clear cut is the best and often the only thing you should do. When do you think I'm going to tell you that is? It has to do with this.
You high grade.
If a stand has been high graded and it is now under the status of shit, start over, kill it all, burn it down, right? Clear cut the thing and then let competition take over, and natural selection will result in your best remaining trees. Good? So if it's been screwed up, start over again. Round up that pond, kill all the fish, and start over again. Get rid of all the trees and start over again. Good? This was powerful information. I hear a lot there. So this is a picture of a clear cut from my study area on the Cherokee National Forest in East Tennessee. This was about a 2-year-old clear, 1 or 2-year-old clear cut that 5 to 8 years later would become good rough grouse habitat. Okay. So some considerations of clear cuts. 5 to 20 acres is a nice size clear cut. You get one too big and out in the middle, there's just not as much potential use of it. Clear cuts that are long and narrow and irregular shaped are usually better than big square blocks of clear cuts. Yep, you have more edge, okay? The edges of clear cuts, it's good if you can feather those edges. And that doesn't mean drop bird feathers on them. It means grade those edges so they go gradually from forest to early successional habitat. And I'll show you an example of that in a few minutes, okay? I'm gonna talk for about 15 more minutes and we're going to the field. Good? Okay. Where do you put bluebird boxes? On the edge on the ground? on a pole in the ground. Okay. You don't put them in the forest interior. You put them in a forest edge. You know, bluebirds like earlier successional habitats, right? So we think about leaving snags for wildlife in the forest, and that's fine. There's plenty of species that use them, but bluebirds aren't going to use bluebird boxes in the middle of the forest. So why would we want to leave a few standing dead trees out of the middle of the clear cut for those species of cavity dwellers that need foraging or cavity habitat in an early successional habitat? Keep in mind though, those snags aren't going to last forever. A standing dead tree will only stand up for a few years before it falls, right? So what else would it be nice to leave a few of in the clear cut? Just a few standing live trees, so that when those snags go, you'll have future snags in the coming years as that forest grows up. Does that make sense? Now we're thinking about all the diversity of species that might be using that. It's best the clear cuts aren't on super steep slopes. There was a lot of clear cutting that went on in Oregon when I was there. This is rainforest, a lot of rain, super steep slopes in the Cascade Mountains. And 2 or 3 times in the 6 years I was there, they had massive mudslides due to clear cuts that just covered up Interstate 5, completely covered it up. Don't do clear cuts on steep slopes. If you do, they shouldn't go this way down the slope. They should go sideways along the slope so that runoff water isn't passing over that open ground for very long before it gets to forest again to slow it down. Right? Okay, so this is an example of a seed tree cut. It's conifer forest instead of hardwood. But you see it's an open canopy, sunlight is hitting the forest floor, but there's enough trees to drop seeds to regenerate the next stand, okay? Here's a drawing, you know, just, it's pretty open, but there's just enough trees scattered out to drop those seeds. These are examples of shelter wood cuts. There are more trees. They're not just to drop seeds, they're to provide shade, okay? So here's an original uncut stand. Here is a stand 15 years after you've established it. You see the second generation coming up, and then 40 years after establishment, you know, they're fully grown. So those are all examples of even age selection. Selective cuts, uneven age selection, group selection or single tree selection. This is from above looking down on a canopy where you have punched some holes in the canopy with group selection. Here's another angle where you can see the sunlight, they're big enough, and you can see that's dark. So the sun is coming in at an angle, and you're not getting the sun hitting the forest floor. So these group selection cuts aren't very big here. Here, based on the slope and the size of the cuts, you can see the sunlight is getting through the bottom of those cuts. That's what it looks like. You just take a little group of trees. It might be a quarter of an acre, half an acre. I hear some people say, oh, a group selection cut needs to be at least 5 acres. Well, that's a little clear cut. I mean, that's a big group selection cut. And I don't like anybody who's saying it needs to be at least 5 acres has an agenda. And I would want to poke them to find out what it is. I wouldn't really trust them very much. Okay. Good. In single tree selection, a tree here, a tree there, and depending on what your goals are, that's what you decide which trees to take. Okay? Good. You might think, well, I've got a forest where for the most part it's pretty evenly established trees, but there's a few places where the trees are kind of dense. So I'm going to take some of the trees where the trees are kind of dense so that it's all nice and homogeneous. So the trees are all kind of evenly spaced. And that, if you have OCD, anybody here have kind of OCD? That kind of might appeal to your sense of order and consistency, right? Is that a good thing or a bad thing to do that though?
Bad thing.
Why is it a bad thing?
Because they need to have, say with the mass producers, you need to have different things because each mass gives them different nutrients.
Yeah, diversity is good, okay? And just as there are some species of, let's say, owl, who's going to benefit from a little bit wider spacing of trees on the floor where they can hunt at night for those mice on the forest floor, there are also species of animals that are going to benefit from places where the trees are a little bit more clumped. Maybe where smaller birds can escape from avian predators by dodging in and out among the trunks. Trying to make the whole forest look the same is lowering your biotic diversity. Sameness doesn't just refer to species, it also refers to structure. This is what we call horizontal heterogeneity, okay? We don't want it to be horizontally homogeneous, we want it to be different as we look at it across the run. And vertical heterogeneity. We want there to be different canopy layers and different heights of trees, right? So vertical and horizontal heterogeneity is a good thing. Maximizing diversity is good. There are some case-selected species who might only use a few species of tree. That's fine. There are a whole lot of species that use a lot of diversity. Large pulpwood monocultures, like pine plantations or biological deserts, that's bad. And if you have diversity, it reduces the likelihood of a mast failure. For example, you might have climatological or weather conditions one year that cause all of the white oak acorns to die, but the red oak acorns don't, or vice versa. Having both red oak and white oak acorns increases the chance that you're going to continue to have a mast. Let's talk about that for half a second. How often do we have bad mast years? How often do we have great mast years? general rule of thumb, and this comes from my old boss, Jim Byford, some of you might know, Dean Byford, said that on average, you'll have one great mast year out of 4. 1 year out of 4 will be a mast failure. And 2 years out of 4, you'll have average mast production. Okay? General rule of thumb. So you're going to have mast failures on a regular basis. So having diversity accounts for that. If a stand loses all of the hard mast one year, all of the nuts die, do the squirrels die or go away? No. What do?
And something else.
Yeah, they eat grapes and get kind of skinny. Maybe a few of them die. They don't produce as many young, but they make it by. And the more diversity you have, the better they're going to do making it through, right? Maximizing diversity reduces the likelihood of a disease epidemic. If you're managing for a whole lot of ash trees over the last 10, 20 years, you might be kicking yourself now, because what should you expect to be happening in the next 10 to 20 years to your ash trees? Die due to emerald ash borer, right? If you don't have as many ash trees, if you have a greater diversity of trees, it's going to be harder for those emerald ash borers to find them, and that die-off will come more slowly, right? So greater diversity buffers against heavy disease die-offs of trees. Maximizing structural diversity, heterogeneity, size, vertical heterogeneity, density, grouping, horde. I just said all that. Consider aspect, soil type, diversify patch sizes. That rule of thumb that I've said in another class that some of you have been in is how big should your patches of different habitats be? A few great big patches, a medium number of medium-sized patches, a whole bunch of little bitty patches is a good rule of thumb, right? So if I'm managing 20,000 acres, I might not mind having a couple great big clear cuts of 20, 30, 40 acres. And then I'll have more clear cuts, that are maybe, 10 or 15 acres, and then a bunch of small group selection cuts. I'm mimicking that disturbance regime that those species are adapted to over the past several thousand years, right? Good. Anybody need a sip of my coffee? Liv? It's pretty good. No? Okay, all right. What's the difference between single tree selection and thinning?
What is the difference?
So the difference is somewhat philosophical or goal-oriented in nature. It often can look the same. A thinning is something we do as an intermediate treatment while a stand is growing, okay? And the purpose is to improve the conditions of the stand for whatever your goals are for the remaining stand. A single tree selection is not, your focus is not as much on the remaining stand, although you certainly don't want to mess it up. Your focus is on the trees that you're taking out for harvest. Single tree selection is about harvest. Thinning is about improving the quality of the stand. Does that make sense? It could actually be doing the same thing, but it's just different goals. So if you're thinning to improve the quality of the stand, don't just go out there arbitrarily with your chainsaw and say, okay, today's my annual thinning day, let's see, and start whacking away, right? Better to take 2 or 3 or 4 years, find your best mass producers. Keep in mind that red oak acorns, it takes them a couple of years to mature. White oak mature in a year. Be sure that you're not high grading, maintaining structural and species diversity, considering groups of trees. So if you're thinking, I think I want to do a thinning, tell yourself, I'm going to do it in a couple of years. I'm going to go out this year, and maybe I'm going to take a paint can and mark my best mass producers, and maybe with another color mark the ones that I think might be good for thinning. And make notes in a notebook and go out again the next year and mark my best mass producers and mark the ones that I think might be good for thinning. And then, based on 1 or 2 years worth of observations, say, okay, yeah, consistently, this is a bad tree, or this one I thought was bad, but it's actually pretty good, I'm gonna keep it, okay? So take your time, because, if you screw up a prairie, you can just round up and start over and you'll have another prairie next year. If you screw up an 80 or 100 and 150-year-old forest stand, it's gonna take your grandchildren to see the fruits of fixing it, right? So take your time with the forest. The stakes are higher if you screw up. Got 3 more minutes. Can y'all make it 3 more minutes? Anybody ready to tromp around outside? I am too. Okay. So when we regenerate, there's some general rules of thumb. Often, when we're replanting stands, a common stocking rate, not always, but often, is something like a 10-foot by 10-foot spacing. And that comes out to 435 trees per acre, okay? Now, we usually do that with an understanding that a bunch of these trees are not gonna survive, okay? So you know, it's not uncommon to have 50% mortality in some of these plantings. Tennessee Wildlife Resources Agency, the West Tennessee Forester, Jason Maxedon, the current director of TWRA, was the first West Tennessee Forester for TWRA. He's a graduate of our program. For a variety of reasons, his plantings, and you're gonna go see some soon, his plantings were seeing survival rates of like 90-95%, which was just unheard of. That's great, but usually we don't expect that many trees to die. So a lot of his old plantings, we're going in and thinning out rows of oak trees just because they survive so well. That doesn't usually happen, right? Usually they die on their own. Why do you plant so many in the first place then? Because if you don't, what you're gonna have growing is light-seeded pioneer species that will outgrow those oaks and shade them out. Like, can anybody think of examples? Sweet gum, good. Cottonwood, sycamore, those are all a light-seeded, fast-growing species. And so by planting a 10 by 10 foot spacing of hardwoods, that hopefully suppresses those other species from outcompeting them, right? And then as those hardwoods form a full canopy, you can thin them, and their canopies will continue to capture the sand and hold it. That's where trees are competing. I mean, down here a little bit, but up there mostly. Don't look at the trunks when you're wondering about competition. Look at the canopies. So a good target density that you're ultimately hoping for is about 50 to 60 trees per acre. And you know, if you're thinking about, you know, timber value, you know, you might get on average $2,000 an acre, but guys, that ranges wildly, okay? You can get $100 an acre, you can get $20,000 an acre. It depends on many factors, including the quality of your trees and the timber market when you happen to cut, which varies a great deal, okay? So stand density is similar to but different from basal area. Did you guys learn about this in dendrology? Yes? Okay, all right. So stand density refers to the number of merchantable trees per acre. And that's a very general measure because, you know, a small tree might be merchantable, but it's not worth very much. And it counts just as much as a tree that's worth 50 times more, right? So foresters more often use basal area, BA, which is the cross section of square feet or meters of wood per acre or per hectare. So, you know, if this is an acre, you can just cut all the trees off and look from above down on their, you know, the stumps, you know, how much wood, you know, is that. I said per acre or per hectare. Why did I not say per hectare?
That's not a thing.
That's not a thing. Excellent. Thank you. There's no such thing as a hectare. That's right. So what is a hectare? We'll start with generally what is it?
Measurement.
It's a unit of measurement. And you can even be a little bit more specific than that, can't you? It's a unit of what kind of measurement? Metric measurement. Area. Of area. It's a unit of area measurement in the metric system. That's right. That's right. How big is it?
100 acres? Close.
You can't, your acres is English, so we're not gonna go there. It's 100 something
No, it is 100 something.
by 100 something.
Is it 100 meters?
Yeah.
By 100 meters?
Yeah, that's exactly what it is. 100 meters by 100 meters, okay? which is kind of sort of the size of a football field if it were square instead of rectangle. Okay, yeah, there we go. It's about 2.47 or 2.49, just under 2.5 acres. Okay, good. So 2.5 acres are in a hectare. A hectare is close to 100 yards by 100 yards. It's 100 meters by 100 meters, roughly the size of a football field. Okay, so if we're measuring meters of square meters of wood, we measure it per hectare. If we measure square feet of wood, we measure it per acre. And we use this device called a prism, and I'll show you how to do that later this semester. Some of you have already done that in dendrology. You've used a prism before? Okay, we'll do that again, which is a cool, easy way to estimate how much wood you have. Now, this is usually done for timber, to determine the potential value of a stand. But the amount of trees we have is often a wildlife-related goal too. So a target basal area for recreation might be 40 to 60 square feet per acre. For timber harvest, 60 to 80 square feet per acre. To maximize mass production, 80 to 100 square feet per acre. So it's not just about the value of the trees, it's about what our goals are, including our wildlife-related goals. So this is 40 trees per acre. And this is pretty good habitat for red-headed woodpeckers that like kind of open forest, okay? This, I know it's conifer, but it's 80 trees per acre. It's twice as dense. It's not as good for that species, okay? So keep it in mind, basal area is a more useful measure. We measure it with a prism than stand density, the number of trees, okay? You're likely to see those definitions on the next test, be able to distinguish those two things. Okay? Good? How about we stop there and go tromp around?
Are you
Yes.
gonna post this on campus?
Have I not done it yet?
I don't think so.
I'm sorry, yes, I definitely will. I will post it on campus.
Are we also gonna go back and finish the food plot PowerPoint?
There was a couple slides we didn't do.
You're right.
They're
We
on
sure will.
campus,
We sure will. They are on campus, but yes, we will go back and finish those sometime.